Hi there. Your Unit 9 test is coming up, and it covers perimeter and area of a variety of polygons as well as circumference and area of a circle. And so we are going to do one of each type of shape so that we can gain familiarity with the process. Each of these problems are coming from your worksheets for this unit, so we're going to look at 9.1, 9.2, and 9.3. as well as 9.4, which is the newest lesson that we've learned. Okay, so when we are looking at rectangles or squares here, which are both special types of parallelograms, and we're trying to find perimeter, we find the perimeter of a polygon by adding all the sides of the shape together. And so for this rectangle, since this side's 5, this side has to be 5, and since this side is 9, this side has to be 9. And so a perimeter, we'd add them all together. We'd do 5 plus 9 plus 5 plus 9, each of the 4 sides. And so our perimeter would be 28. And for perimeter, since we are just adding sides together, we aren't multiplying the sides, it's just 28 centimeters. And so that's how you'd find the perimeter of a rectangle or of a square. Okay, sliding down here, let's look at a circle. With a circle, we are finding circumference. Circumference of a circle, we use the equation circumference equals 2 pi r, where r is the radius. It's halfway across the circle. And so in number 4 here, we're given our radius. Number 6, we're given our radius. Number 5, though, we're given all the way across. All the way across is 16. So the number I want to put into my radius up here is going to be the halfway across, which will be 8. Okay, and so we'll demonstrate that with number 4 here. Circumference equals 2 pi, and my r, the halfway across, is 16. And so my circumference, 2 times 16, is 32 pi. 2 times 16 is 32. And since I'm not giving units, I'll go ahead and express this as 32 pi units. And that's how you find circumference of a circle. Okay, sliding up, we have find the area of a rectangle with the given base and height. So we have a rectangle here with a base of 4 and a height of 15. And I want to know what is its area. Well, area of a rectangle, area equals base times height. And height for rectangles, parallelograms, trapezoids, triangles, height always has to come down at a right angle. So we want to make sure we keep that in mind. With a rectangle, all angles are right angles. And so we would have area equals 4 times 15, which is 60. And since it's area, we use feet squared. Okay, numbers 12, 13, and 14, we're asked to find the area of a circle. Area of a circle is pi r squared. And again, r is halfway across the circle, so right here for number 12, we have a radius. Number 13, we have the entire diameter, so we'd have to cut it in half to get the radius. And same with number 14, we have the entire diameter, so we'd have to cut it in half for the radius. And so we're going to do number 13 here. We have pi, whatever our r is, squared. And our r is halfway across the circle. Well, if the whole way is 200, half the way is 100. And so my area is going to be 100 squared, which will be 10,000 pi. And since I'm not given units, I call it units. And since it's area, it's units squared. Okay. Next up, let's take a look at a parallelogram here. For a parallelogram, area of a parallelogram is base times height. And height has to come down at a right angle. Okay, and so when we're looking here at number 1, this right angle helps us see our base and our height. Our base and our height are going to be the 8 and the 10, not the 9. In number 2, our base and our height are going to be the 12 and the this side. Well, we aren't initially told what this side is. However, right across the way from the parallelogram, I know its opposing side, its parallel side, is 8 millimeters, and so this has to be 8 millimeters as well. Therefore, my base and height are 12 and 8. Number 3, my base and height are 4.8, and whatever this side would be, and this side is 2.5. Now notice, I didn't include this piece of the segment in my base, because this piece is not actually part of our parallelogram. It's been extended here just so we can see where the where the perpendicular height comes in. Okay, but this piece is not part of the parallelogram, so we don't count it. And right here in number 4, we have our base and our height. So our height is our 2 here, and our base is whatever this top side would be, which this top side is 7.5 meters. And so we'll go ahead and finish off number 4 and actually apply the area formula. Area of a parallelogram is base times height. And we just got through saying my base and my height are 7.5 times 2, which is 15. And since it's area, we use meters squared. Okay. Sliding down here, let's take a look at a triangle. A triangle's formula is 1/2 base times height. And again, the height needs to come down at a right angle, so when we're looking at these, for example, in number 9, my height is 5.5, my base is 7. Again, notice we don't count the 2 in there because this 2 is not part of the triangle. And so we would do area equals 1/2 the base, which is 7, times the height, which is 5.5. Which would give us 1/2 times 38.5, which is 19.25, and since it's area, we use inches squared. Okay. Moving on, let's take a look at a trapezoid. Okay, so area of a trapezoid, area equals 1/2 sum of the bases times the height. And again, height has to come down at a right angle. So right here in number 1, or 2 and 3, but we're going to do number 1. Number 1, we're looking at 1/2 sum of the bases. My bases are the 9 and the 16. The bases of a trapezoid are the two sides that are parallel to each other. So 9 and 16. And my height is what comes down at a right angle, in this case, 10. And so we get 5 times 25, which is 125, and since it's area, we use feet squared. Okay, 2 more shapes here. We have our kite. Okay, to find the area of a kite is 1/2 diagonal 1 times diagonal 2. Okay, diagonals are the lines that cross from corner to corner through the kite. And so in this case, one of our diagonals is going to be right here. This is 4 and 4, which makes 8. And its height is 2 and 6.5, which makes 8.5. And so we get 4 times 8.5, which is 34, and since it's area, we call it feet squared. Okay, last shape, we have a rhombus. A rhombus has the same formula as a kite. Area is 1/2 diagonal 1 times diagonal 2. The interesting thing about a rhombus is if you know 1/2 of a diagonal, you know the other as well, because in a rhombus, the diagonals bisect each other. And so in this rhombus, since this side is 25, its opposing side will also be 25. And since this side's 22, its opposite side will also be 22. And so you get area equals 1/2 sum of the bases. So this is 20, sum of the bases. 1/2 diagonal 1, so we are going to sum the two sides to get diagonal 1. So 25 plus 25, which is 50, and 22 plus 22, which is 44, which is 50 times 22, which is 1100, and since it's area, we call it feet squared. Okay, the last part here is the most recent lesson, which is how to find the perimeter of a shape on a coordinate plane. More specifically, we were looking at how do you find a missing side length. And we find a missing side length using the Pythagorean theorem, which was a squared plus b squared equals c squared. Remembering that a and b are the two sides of a right triangle, and c is the hypotenuse. It's the longest side, and it's across from the right angle. Right? And so for example, in number 1 here, when we are asked to determine whether the triangle is scalene, isosceles, or equilateral, well, the only way to be able to classify a shape, the only way to find those missing sides, the only way to find perimeter, if we are then asked to do so, is to be able to use Pythagorean theorem. And so we have here zy, and I want to know its side length. And so I'm going to do that by drawing in a right triangle. This right triangle just hangs off the side of the triangle I'm actually trying to classify. Right? And in drawing in this right triangle, I now have an A, B, and the C that I'm trying to find. And so my A in this case is 2. Right? 1, 2, it's a length of 2. So my A is going to be 2. My B is going to be 1, 2, 3, 4. And then my C, which is my unknown side, my zy here. Well, 2 squared is 4, and 4 squared is 16. 4 plus 16 is 20. And if I square root both sides, I get root 20 is what C is. And so then I can label this side here root 20. And I'm going to do the same thing on all of them. Right here to find yx, I'm going to draw in my right triangle. And then my A down here is going to be 2. My B right here is going to be 4. And my C is my unknown side, so I have 4 plus 16, which is 20. And so root 20 equals C. And so I already know from the work I've done that this is not a scalene, because a scalene triangle, none of the sides would be the same. Okay, it's either an isosceles, because 2 are the same, or it's an equilateral if this third side is also root 20. And so we need to find that third side. Well, if I draw in my right triangle, right here, I now have my A, which is 2, my B, which is 1, 2, 3, 4, 5, 6, and my unknown C. And I can already tell that this side is not going to be the same length, right? 2 squared plus 4 squared versus 2 squared plus 6 squared. And this last side is, in fact, root 40. So it is not the same side length. Therefore, this triangle is an isosceles triangle. If I was then asked to find the perimeter, I would simply add those three sides together, root 20 plus root 20 plus root 40, and I'd have the perimeter of my triangle. So in summation, anytime you're wanting to find a missing side, draw a right triangle in, and it can either be below the side or above the side, it does not matter, but you draw a right triangle in that would allow you to use your missing side as your C in your Pythagorean theorem.